One of the things about a moment is when you do a moment, the force must be at right angles. So if I'm applying force at that point there, the moment equals the force times the distance, and it's going to be the perpendicular force. But what happens if that force is not at right angles? And there's two basic ways that we can approach this, but both of these end up with m is equal to force times distance cos theta. And we've got to figure out which angle is theta. So let's look at the two ways we can actually approach this. If we have a force, let's apply our pivot here. Let's say we apply a force this way. And now that's not going to be quite right angles. And in fact, I'm going to set this up. This is 20 degrees off perpendicular, and the size of the force is 20 newtons. Now there's two ways we can do this. We can either take, if we know the force is like this, and it's going to be at 20 degrees. Remember, because these are parallel lines, 20 degrees here is the same as 20 degrees here. If I know it's 20 degrees, I can take the y component, the vertical component. How do I work out that? Well, the force per this here, x is going to equal the size of the force. If I make this into a right angle triangle, that's going to be cos theta, where theta is measured from the perpendicular. So basically what I want to do, I imagine I want to find out the force coming down here perpendicular. How far is it away from that? So I can say, therefore, work is equal to the force cos theta times this distance here. The other way of doing this, sorry, it's not the work, that's the moment. Sorry, my apologies. Moment is equal to force cos theta, and the cos theta gives us the perpendicular component times the distance. Or I can say what happens if I extend this line, right? And if I want to find out where it's closest, it's going to be closest at tangent. So I can use this distance. This is distance x. How can I work out that? Well, if I take this angle here, this distance is going to be adjacent. The hypotenuse is going to be cos related to cos theta. So in this case, distance is equal to distance x equal distance cos theta. And so the moment is going to equal force distance cos theta. You'll basically notice in both the versions of this, force cos theta d, force distance cos theta, they've both got a cos theta thing in. But the big thing is, where am I measuring this from? So this theta here is going to be the same as that theta there. This is going to be also 20 degrees. 20 degrees. Now this seems confusing the first couple of times you see it, but basically what we're doing, so in this example, the moment is going to equal the force, which is 20 newtons, times the distance, which I'll make that equal to 2 meters. D is 2 meters, times cos 20 degrees. And then we use something magical called a calculator. And we go 20 times 2 times cos 20 equals 37.59 Newton meters. And we can tell that this is probably correct because this is smaller than that. So let's do this again just quickly as a conceptual thing. What we're doing, let's tidy up here, is if we have a force being applied at a distance, and we have a force coming in at an angle, we measure the distance. Remember, we want to do it as perpendicular. Theta is either going to be the angle away from the perpendicular, well, it's always going to be the angle away from the perpendicular, even here. So what happens here is if we basically measure the angle, the forces from the perpendicular, and we had that cos theta term, it's always going to be accurate. Sometimes it's easier to do it by components, sometimes it's easier to do it by this, but either way you're always going to end up with the formula moment is equal to force times distance times cos and the angle that that force is acting from the perpendicular. Always going to happen. So if you remember that, that will give you the moment always. Thank you.